one more problem on the project network and the calculation of variance and standard deviation expected duration in a network diagram. So here you are given a problem. So jobs are given as 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6 and 5 to 6. So optimistic time, most likely time and pessimistic time are given. So this will be usually given in the problem. So the problem is that a small project composed of 7 activities and the total expected time are as above. So here draw a project network. So we have to draw the network diagram, find the expected duration, that is TE, that is nothing but the mean project time, completion time. So variance with respect to the expected project length, calculate the variance and the standard deviation of the project length. What is the probability that the project will get completed in 13 weeks? So here this part I shall explain to you a little later. So you are given the Z values, okay, and the concerned probability. So this will be given to you in the problem. So if it is not given, you will have to collect the log table, okay. So now the first step is you have to make a list of the activities which are there in the problem. So 1 to 2, 1 to 3, 1 to 4, 2 to 5. So these are all the ones which we have in the problem. So the formula for computation of the expected time is the TE is equal to T0 optimistic time plus 4Tm plus TP divided by 6, and the standard deviation formula is TP minus T0 divided by 6. So variance is nothing but the standard deviation squared. So now going by each of the activities, whatever is given to us in the problem, we will have to just take it from there. So here you are given the values here if you observe. So same things are taken here. So 1, thus it is optimistic time plus 4 Tm plus Tp is 7. So divided by 6 will give you 2. So standard deviation is 7 minus 1 is equal divided by 6 is equal to 1. So likewise we calculate for all the activities. So we also arrive at the standard deviation values. So since you are asked to calculate the variance in the problem, we are taking the standard deviation square. Now we are given the activities, right? So we have to draw a network diagram. So here the network diagram is drawn like this. So 1 to 2, 1 to 3, then 1 to 4, then 2 to 5, 3 to 5, 4 to 6 and 4 to 5 to 6. So this is how we look at the jobs that are there and we draw. So now we'll have to make a note of the expected time that we have calculated, right? So here 1 to 2, the expected time is 2, 1 to 3 it is 4, 1 to 4 it is 3, then 2 to 5 it is 1, 3 to 5 it is 6, 4 to 6 it is 5, then 5 to 6 it is 7. Now working out the all the possible paths here. So we follow the direction of the arrows. So 1 to 2, then 2 to 5, 5 to 6. So that is equal to 2 plus 1 plus 7, which is equal to 10. Next 1 to 3, 3 to 5, 5 to 6, 4 plus 6 plus 7, which is equal to 17. Then 1 to 4, 4 to 6. So here 3 plus 5 is equal to 8. Now if you observe here, the critical path is this. So this is a critical path since it has the largest duration. So while calculating the variance, we have to take up the activities and standard deviations were. Now let us make a note of the activities in the critical path 1 to 3, 3 to 5 and 5 to 6. So it is here the standard deviation for 1 to 3 is 1. So we have calculated it as 1. Then 3 to 5, 3 to 5 it is 4 and 5 to 6 it is again 4. So when we add up all the values, that works out to 9. So standard deviation square is equal to 9. So variance is always standard deviation square. So standard deviation is equal to square root of 9, which is equal to 3. Now we indicate the standard normal variate, which is x minus mu divided by standard deviation. So here in this particular case it will be x minus 17 is the total duration, total time in the critical path. So 17 divided by 3. So now we have to calculate if the project probability that the project will get completed in 13 weeks. So here the probability that the project duration is lesser than or equal to 13 days is equal to 13 minus 17 divided by 3, which is equal to minus 1.33. Correct? So here what we have to do is we have to draw a standard normal curve like this. So this is indicating 0. Okay, so this is the new value here. So now to the left side of the standard normal variate we have the negative value. So from here it is minus mu. Okay, from here it is 0 to plus, is it not? So here if you observe here minus infinity and plus infinity, so here minus 1.33 it lies here. So here if we observe, I have to find out the table value for this particular region. Okay, so this is the identified region. Now the point here is in the standard normal distribution, in the standard normal distribution table, I will be able to get the values from here to here. Okay, so if you take the standard normal curve, so this whole region is 50% and here it is 50%. Okay, so what I have to do is I will be getting values from here to 0 to minus 1.33. So this whole region is 0.5. So out of 0.5 I have to look into the value for 1.33, which is very much given to you in the problem as the probability is 0.0918. So this I shall deduct 0.0918 and 0.4082 or 40.82% is the probability that the project will get completed in 13 days, less than or equal to 13 days. As I told you, if you observe the standard normal distribution table, you get the table values from 0 to here. This region is we have to deduct from 0.5 and find out. So this is how we compute the probability problems under PERT.